Example 3. Compute first and second order partial derivatives of f of x and y equal to x e to the power xy plus y squared minus y times quantity x squared plus 1 in parentheses. First thing that I want to do, first order derivative means f sub x and means f sub y. So for f sub x, start with first term of the function of two variables. And I see that basically it's a product of two factors. The first factor contains x, the second factor contains x, therefore I'm going to use a product rule. So product rule for this would be partial of x with respect to x, which is 1, times e to the power e to the power xy, then plus, and then this time x, then derivative of e to the power xy, partial of that with respect to x. So partial of exponential, it's itself times the derivative of the exponent. Derivative of the exponent is partial of xy with respect to x, and that would be y. So this entire thing is partial of x e to the power xy over partial x. Now, the second term is in terms of y only, therefore I get 0. The third term is y times x squared plus 1. So y is the constant coefficient in here because I'm finding partial of this term with respect to x, and derivative of x squared plus 1 is 2x. So I get minus 2xy. Let's clean it a tiny bit and get rid of the extra stuff. Now, how do I do f sub y, or partial of f with respect to y? Here again, I have to take the partial of the first term, but remember, x in here becomes a constant coefficient. Rather than a product rule, you will have a constant coefficient times the derivative of exponential, which is going to be itself, times the partial of the exponent with respect to y here. So it's x squared e to the power xy. Then derivative of y squared is 2y. Derivative of something, this is going to be the constant term in here. X squared plus 1, quantity x squared plus 1 is going to be a constant term times y. So I get minus x squared plus 1. And if I clean it up, I will get this value. Now, let's take the second derivative, one of the second derivatives. And so when I have f sub x, then I can either take f sub x sub y, or I can do f sub x sub x. So let's start with f sub x sub y. And over there, I get from here, e to the power xy again, itself, derivative of exponent with respect to y, because I'm starting from here, going there. And what I want to do is basically take the derivative of this entire quantity with respect to y. And so derivative of exponent is going to be x. Now, derivative over here is a product rule. Because I'm taking derivative with respect to y, basically x is a constant coefficient, but this still requires a product rule. And so what I get is going to be x as a constant coefficient times derivative of y, which is 1, plus xy remaining, e to the power xy, derivative of the exponent, because derivative of e to the power xy is e to the power xy times derivative of the exponent with respect to y. So I get another x squared. Over here, negative 2x is the coefficient and y is the variable in there, basically. So if I clean it up, I'm going to put these two together and get 2x e to the power xy plus x squared y e to the power xy minus 2x. And remember, this part of it was the partial with respect to y of xy e to the power xy. Now let's do f sub x. So again, I'm going to go from here to here. Derivative of e to the power xy with respect to x this time around is going to be e to the power xy times derivative of that with respect to x, which is y. Now, the next step is to take the derivative of xy e to the power xy, which I know y is the constant, so it's going to be a product rule because x is here also and over there. The derivative of the first derivative of xy is going to end up, with respect to x, is going to end up to be y. Then I will have to take the derivative, multiply xy times derivative of the exponential, which is itself. Then with respect to x, I get another y. And derivative of minus 2xy is going to be minus 2y. Clean it up again and you get 2y e to the power xy plus x y squared e to the power xy minus 2y. And this was the part was product rule. Now let's try to go from here and find maybe fyx. So fy then with respect to x, and over here I see x squared e to the power xy, a product rule, 2x e to the power xy, and then plus x squared, derivative of this with respect to e to the power xy with respect to x is itself, times derivative of exponent with respect to x, which is 1. Then I will get a minus 2x and a 0. Wait, right here, let's check our answers. It turns out that there are two f sub xy, so if I take the derivative respect to x, partial respect to x, then respect to y, is the same thing as if I take the derivative respect to y, then respect to x. And this is no accident. According to Claira's theorem, if the second derivatives are all continuous, this is going to happen every time. The last thing that I want to check is f of y, or I want to find. F of y, x squared is a constant in here. Take the derivative of the exponential with respect to y, so I get e to the power xy. And then derivative of exponent with respect to y is going to be x, so x to the power 3. Then derivative of 2y is just 2, and the rest of them are going to be 0. So this is f sub xx, this is f sub yy, and these two are the mixed partials.